Hello my dear students, welcome to my physics class. Our today's topic is radioactivity. Radioactivity. Radioactivity is the process by which an unstable atomic nucleus loses energy by radiation. That is, radioactivity is a process by which unstable atom emits radiation. A material containing unstable nuclei is considered as radioactive material. That is, the material containing unstable nuclei is considered as radioactive material. The radiation emitted from the radioactive nucleus is known as radioactive ray. Here the material is known as radioactive material, and the radiation emitted from this material is known as radioactive ray. That is, the material which contains unstable atom nucleus is known as radioactive material, and the radiation emitted from this type of material is known as radioactive ray. The main three radioactive rays emitted from the radioactive nucleus are alpha, beta and gamma rays. That is, from this type of radioactive materials, alpha, beta and gamma rays are emitted. These alpha, beta and gamma rays are known as radioactive ray, and the material from which alpha, beta and gamma rays are emitted is known as radioactive material. What causes radioactivity? Atoms found in nature are either stable or unstable. That is, there are two types of atoms in the nature, stable and unstable atoms. An atom is stable if the forces among the particles that make up the nucleus are balanced. That is, we know atom consists of nucleus and electrons, and nucleus consists of neutron and proton. Proton is positively charged and neutron is chargeless particle. That is, the forces among this proton and neutron is balanced. If the forces among this proton and neutron are balanced, then this atom is stable atom. An atom is unstable, that is radioactive, if these forces are unbalanced. If the nucleus has an excess of internal energy. That is, unstable atoms are radioactive atoms and stable atoms are non-radioactive atoms. Instability of an atom's nucleus may result from an excess of either neutrons or protons. We know there are a certain number of proton and certain number of neutron in a particular nucleus. If this number of protons and number of neutrons are unbalanced, then this type of nucleus are unstable nucleus. If an atom has an unstable nucleus, like when it has too many neutrons compared to protons or too many protons compared to neutrons, radioactive decay happens. That is, if the atom has excess proton or excess neutron, the atom is unstable, and this unstable atom is radioactive atom. The atom ejects out beta or alpha particles depending on the type of radiation and begins to lose mass in the case of alpha particle. If the nucleus emits alpha particle, then it will lose mass in order to form a stable isotope. That is, the unstable atom will emit alpha particle, beta particle or gamma rays, and it will be stable. Alpha rays. Alpha particle or beta alpha rays consist of two protons and two neutrons bound together into a particle identical to a helium-4 nucleus. That is, alpha particle means there are 2 protons and there are 2 neutrons, and we know in helium atom there are 2 protons and 2 neutrons, and there are 2 electrons. And in the nucleus of a helium there are 2 protons and 2 neutrons, and alpha particles are also consist of 2 protons and 2 neutrons. Therefore alpha particles is known as helium-4 nucleus. The symbol for the alpha particle is alpha, Greek letter alpha or alpha 2 plus, because there are 2 charges. The charge of alpha particle is +2, therefore here alpha 2 plus. Because they are identical to helium nuclei, they are also sometimes written as helium 2 plus or 4 to helium 2 plus. Here 4 is the mass number and 2 is the proton number, that is atomic number. We know atomic number of helium is 2 and mass number is 4. Therefore helium 2 plus, this is the nucleus of helium, or helium 2 plus, this is also the nucleus of helium, indicating a helium ion with a +2 charge, missing its 2 electrons. Alpha rays. Here parent nucleus, that is A, Z, X. Here Z is the proton number and A is the mass number. And if this atom or this nucleus emits alpha particle, we know alpha particle consists of 2 protons and 2 neutrons. Therefore the proton number will be Z minus 2 and mass number will be A minus 4, because here mass number of alpha particle is 4, because and here 4 nucleons, 2 proton plus 2 neutrons. Therefore here mass number is 4 and proton number is 2. Therefore for the daughter nucleus, proton number will be Z minus 2 and mass number will be A minus 4. Some properties of alpha rays. Alpha particles are positively charged. We know there are 2 protons and 2 neutrons. The charge of proton is +1. Therefore here 2 protons. Therefore the charge of alpha particles are +2. They have kinetic energy of about 5 mega electron volt. They are ionizing radiations, that is these particles can ionize the gas. Alpha particles strongly ionize the gas through which they pass. The penetrating power of alpha particles is very less. Their path can be blocked by paper, that is the path of alpha particle can be blocked by paper, therefore their penetrating power is very less. They are quickly deflected by electric and magnetic field, because the alpha particle has +2 charge. Therefore they are strongly influenced by electric and magnetic field, so they are quickly deflected by electric and magnetic fields. Alpha particles affect a photographic plate. Beta rays. Beta decay means emission of electron or positron from the nucleus of the radioactive atom. We know radioactive atoms emits alpha particle, beta particle and gamma rays. Alpha means helium of the nucleus and beta means emission of electron from the nucleus of the atom. And there are 2 types of beta decay, positive beta decay and negative beta decay. If the nucleus emits electron, it is negative beta decay, and if the nucleus emits positron is the antiparticle of electron, and electron or positron may be emitted from the nucleus of the radioactive atom. If the nucleus emits electron, it is negative beta decay, and if the nucleus emits positron, it is positive beta decay. Emission of electron from the nucleus is known as negative beta decay, and emission of positron from the nucleus is known as positive beta decay. If the nucleus has excess proton, we know the radioactivity happens due to the unbalanced number of proton and neutron. If the proton number is excess or neutron number is excess, the nucleus is unstable nucleus and it is radioactive. If the nucleus has excess proton, then the proton will be broken down, and proton is equal to neutron plus positron plus neutrino, and this is known as positive beta decay because here positron will be emitted from the nucleus. Here proton will be broken down and it will form neutron, chargeless particle, and positron, the antiparticle of electron, and neutrino. Here positron will be emitted from the nucleus, therefore it is positive beta decay. And if the nucleus has excess neutron, then neutron will be broken down, and neutron is equal to proton plus electron plus antineutrino. Here electron is the negatively charged particle, and as the nucleus emits electron, then it is negative beta decay. That is, if the number of proton is excess, then positive beta decay, and if the nucleus has excess neutron, it is negative beta decay. Here negative beta decay and here positive beta decay. Here carbon 14, there are 6 protons and 8 neutrons. 6 plus 8 is equal to 14. We know carbon 12 is a stable isotope of carbon, and there are 6 protons and 6 neutrons. But here the number of neutron is 8 and number of proton is 6. Here 6 means atomic number of carbon is 6, that is 6 protons. It is the identity of carbon, and 8 neutrons. Here excess number of neutron, therefore the neutron will be broken down and it will produce a proton. Therefore 6 proton plus 1 proton is equal to 7 proton. Now it is nitrogen because proton number is the identity of an atom. Therefore here 6 proton number 6 means carbon and proton number 7 means nitrogen. Here 8 neutrons, 1 neutron will broken down, therefore 8 minus 1 is equal to 7 neutrons, 7 proton, 7 neutron. Now nitrogen 14, and antineutrino, we know from the neutron, proton, antineutron and electron will be produced, and this electron will be emitted from the nucleus, therefore it is negative beta decay. And here carbon 10, it is also unstable isotope of carbon, and here 6 protons and 4 neutrons, that is neutron number is very less. Here excess proton, therefore proton will be broken down and proton will form a neutron, therefore now proton number is 6 minus 1 is equal to 5, and neutron number will be 4 plus 1 is equal to 5. Here 5 protons and 5 neutrons. 5 protons means boron. Now the mass number is 5 plus 5 is equal to 10, and neutrino, you know, from proton, neutron plus neutrino plus positron will be produced. Here positron will be emitted from the nucleus, therefore it is positive beta decay. Some properties of beta rays. Beta particles are the fast moving electrons emitted from the nucleus of an atom. We know beta emission mean emission of electrons, that is beta particles are the fast moving electrons emitted from the nucleus of an atom, and the speed of beta particles is of the order of 10 to the power 8 meter per second, very high velocity. Beta particles ionize the gas through which they pass, that is they are also ionizing particles, and penetrating power of beta particle is more than that of alpha particles. The penetrating power of alpha particle is less because it can be blocked by paper, but beta particles cannot be blocked by paper only. Beta particles affect a photographic plate. Now gamma rays. Gamma radiation are the electromagnetic waves like X-rays and light. X-rays are also electromagnetic wave and light is also electromagnetic wave. Gamma radiations are the electromagnetic waves like X-rays and light, but they differ from X-rays and light in wavelength. The wavelength of gamma rays, X-rays and visible light are different, and gamma rays are emitted from the nucleus of the atom, and X-rays are emitted from the atomic orbit of the atom. Here gamma rays are emitted from the nucleus. Some properties of gamma rays. The speed of gamma radiations is the same as the speed of light because it is electromagnetic wave. It has no charge or mass, it is chargeless and massless. Its wavelength is very low. It cannot be influenced by any electric or magnetic field because gamma rays has no charge, so it is not influenced by any electric or magnetic field. To stop the gamma rays with energy equal to that of alpha and beta particles, a thick layer of lead of several centimeters is needed.